Hey, in this video we're going to continue talking about higher order functions, and we're going to get into some details about how the most common higher order functions work. So the first one that I want to talk about is findIf. So findIf finds a value in the container that matches a given predicate. And if you remember, predicates are just functions that take an argument, take a piece of data, and they return a Boolean, a true or false value. So for findIf, you want to provide it a predicate that returns true when you're identifying an element that matches what you're looking for. So we will have a container, I'll call it V, with a whole bunch of elements. And then we're going to have a predicate, I'll call it F for function. And this predicate is going to take an integer, it's going to return a Boolean, and what it's going to do is return true for the thing that we're looking for, thing we're trying to match. So if I have a function that returns true for the number 9, then findIf is going to go through this entire container and check, is this a 9? Is that a 9? Is that a 9? Is that a 9? And is that a 9? And this is the first one that will return true. So that's the result of findIf. And so findIf is repeatedly calling this F function for each of the elements in it. All right, next one is index of. So index of is very similar to findIf. It's also known as position. It's trying to find the index of a value that matches the given predicate. So we will have a container, just like before. We'll have a predicate, takes a single value. So in this case, we're pretending that it just stores integers. Integers stored in our container, and we're going to be returning true if it matches. But in this case, let's put some values in here. All right. In this case, the function index of is finding the first one that matches. So say we're trying to find 9 again, or that's what our predicate returns true for. It's going to find that one, but it's going to return the index. So here's index 0, 1, 2, and 3. So it'll return the value 3 in this case. You could have a predicate that returns true for anything less than 4. And in that case, it would compare to this first one and return false, false, true, and return the value 2 because that's the index 2. That's the index of. The next one is filter. So filter, another way to refer to this is remove if not. Filter is creating a new container with only the matching elements left in it. So it removes all of the non-matching elements. So this function takes a container. So here's our container again. It takes a predicate as well. So here's our predicate. Returns a Boolean for each of these values, and it is going to go through the entire container and and it will be adding elements to a new container. So let's say result is going to be a new container. And let's pretend that we have some values in here, 8, 4, 1, 9, 1, 3. Okay. And then what we want is maybe we're given a predicate that's returns true, like if our predicate was just return x less than or equal to 5. All right. So in this case, filter would apply that function to each of these elements, and for ones that returns false, it would ignore those, skip over them. So this is false, this is true, that's less than or equal to 5, so it would put that in the result. This is true, so put that in the result. This is false, this is true. All right, this is true, this is true, this is true. So all of those go into our result here. All right, and then that's what we return. So we've ended up filtering out all of the values that don't match the predicate. Right, so the next higher order function here, commonly used one, is map. So it's also called apply. And map creates a new container that's filled with transformed elements. So you have to be given a container. So here's our container. And then you're given a function. And this function, it takes an integer. Well, this is our data. So this is our input data. We're just using integers for now, and it returns the same type of data. It's possible for it to return a different type of data too, but we're just keeping it simple here. So this is going to act like a transformation of a container to another container, to a new container. So this function transforms the given value. All right. So now when we go through and apply this function to all of the values of the container, we end up with a new container with the same number of elements, but each one of these elements is transformed version of what was in the original container. So let's say my transformation was return x times 2. It's an easy one. So then every one of these values, we would go to the first one, transform this, become 8. Next one, that's 2, add it to my result container. It's 6, and then 12. All right, and that's my result. So you can do this for in a functional programming language. You would do this for other types as well, but the idea is what's important here, the concept. All right, next one is reduce left. So reduce left, sometimes just called reduce or fold or accumulate. It combines all of the elements of a container into one result. This is something that's very commonly done in parallel processing, multi-threading, especially like on a supercomputer. You want to start with a whole bunch of data and kind of collapse all of that data into one final answer. So in this case, this reduce left higher order function starts with a container like we have before. You also give it an initial value. So let me just make one box for that. And you need to give it a function, and this function takes 2 pieces of data and returns 1 piece of data. So it is sort of collapsing 2 pieces of data into one, and reduce left is going to take that function and apply it to every element of this, or every pair of elements in this given container, until you end up with a single value as your answer. So a simple reduce left function could be sum. You could be adding these 2 integers together and returning the answer. So in that case, you would probably start with an initial value of 0. The initial value is going to act as the starting place for this container. So if it was, let's say, initial was 0, and actually let me write it in there. Let's say initial was 0, and we started off with 3, 1, 8, 1, something like this. Then our result is going to be a single value. This is reducing it to a single answer. But we're going to go through and say, like, okay, we start at 0, and let's say we're using sum. So something like return, let's call this A and B. So return A plus B, 2 different values that are turning into 1. So the first one I'm going to do is there when A is our initial value, B is our first element. So now we've got 0 plus 3. So we'll get an answer from that. That's 3. And then we hold on to that. The next run is going to be A is our answer, and B is the next element. So 3 plus 1. Alright, that's going to be 4. And then the next one, A is going to be our answer so far, which is 4. And B is going to be our next element. So combining them using my function here. That's 12. Alright, we'll go to the next one. 1, so we'll end up with 13. And 0, so we end up with 13 again. And 4, so we end up with 17 as our answer. Alright, so that's one example if you were using sum as your input function, as your parameter. But you can imagine lots of other ways to combine these kinds of pieces of data, or just generically any piece of data. So let me try another one. Let me do like, well, I guess double would be pretty easy. So let's do, actually double doesn't work. We want to do one that takes 2 parameters. So let's say, hesitate to do multiply, but I can multiply these numbers. I'm pretty good at multiplication. So let's say A times B. Just looking at these numbers, you should get an idea of what this is going to end up as. So let me get a different initial value. Let's start with 1, because that's the multiplicative identity. Makes sense for this function call. So let's combine them. 3, or 1 actually, we'll start with our initial value, times 3, we end up with 3. And then our second value is 1, so 3 times 1, we end up with 3 again. And then our next value, so the one that we've gotten so far is 3 times 8, so we get 24. And then go to the next one, 24 times 1, we get 24. The next one is a 0, so 24 times 0, we get 0. And then our next one is 4, and that's our last one. And we end up with 0. So our result's going to be 0, reducing this container using multiplication gives us 0. So that could be a useful answer depending on what problem you're trying to answer, what problem you're trying to solve. So that's how reduce left works. Just make sure that you don't get stuck thinking about it as one function. It's any possible function that can take 2 pieces of data and return a single piece of data. All right, and our last one is negate. Negate. All right, so negate. Negate returns a new function. And this is a little different from those other higher order functions. This is the only one so far, the only one out of this collection of them that returns a function. So it has to create a new function. You would do that, by the way, with lambda function syntax. All right, so returns a new function that's the logical negation of the given function. And that's not too hard. It just really depends on your syntax. So it's given a function, and that function can technically be anything, but let's just make it accept one piece of data and return a Boolean. That way it'll be useful in all of our other functions, higher order functions that use this. So like findIf, you could pass a negated function into findIf to be like find if not, that kind of thing. All right, so we got a function, and negate is going to return a function. So essentially, the result is going to be like return, something like this. The logical negation of f, whatever f is. This depends on the syntax of the language you're working in. You may have to like pass in the parameter that was given in order to make it actually perform that operation. But you might also need to use lambda syntax. So let's actually you want to return a function that, so let me see, what's the lambda syntax for C++ is kind of like this. So then here you would do this is int, and if you wanted to do the return syntax, let me do that. There's a little arrow, bool, just to be explicit about the return type, but that's usually optional. And then we want to return the negation of f of whatever integer this is. So let me give it a name, x. There we go, that's better. Okay, that's actually, there you go, that's the C++ version of it. A little hard to explain, but if you understand the syntax, this is creating a new function. All of this is creating a new function. And what this function does is it accepts a piece of data and it evaluates that piece of data using the function that we were given in the first place as an argument to this negate function. It evaluates that, negates the result, and returns it. It is possible in C++. I don't remember. You might have to capture the reference to that function. This is by value. That will probably work. If that doesn't work for you, do the ampersand in front. But test it out, see how it works. All right, so those are all of our common higher order functions, and how they work in theory, and it'll be up to you to implement them and see what kind of cool uses you can have for them, and how it changes the style of programming. It's a very different way to think, and that's one of the fun things about it. It challenges you to think different. All right, I'll see you in the next video.